name is Aleksandra Zieminska-Stolarska, and today, together with Professor Lodz Zieminska, we would like to show you our results that we conducted in a frame of the Monsul project. As you mentioned, Arthur, the title of the presentation is Continuous Automatic Monitoring as a Method of Assessing Water Quality on the example of large water reservoir, which is located in central Poland. Before I start, I would like to say a few words about the project itself. The Monsul project, it was a 3 years research collaborative project that we conducted together with Norwegian Institute for Water Research from Oslo in Norway. And this project consists of 2 parts. So first of all, we conduct continuous monitoring of water quality parameters. And the second part of the project was an integrated 3-dimensional model of the reservoir. It was both the hydrodynamic and water quality model of the lake. Today, during my presentation, I would like to focus on the first part. So I will tell about the continuous monitoring of water in Soleil reservoir. I encourage you to visit our project websites because there are information concerning both the goal and scope of the project and all the presentation and results. This project website is both in Polish and in English, so you can easily follow our results. So I would like to start from the information concerning this artificial lake, the Soleil reservoir. This reservoir is one of the biggest lowland dam reservoir in Poland. It was constructed in years 1969, 1973 by impounding the Pilica River with a dam. The most important parameters of this reservoir is the length of 17 kilometers, surface area is 22 square kilometers, and the parameter, which is very interesting, average depth. It's really shallow artificial lake. It has a depth of 3.3 meters. And the long retention time, it's during the vegetation season is approximately 40 days. So that's why the reservoir is prone to eutrophication problem and especially toxic algae blooms. For nearly 30 years, the main function of this reservoir was supplying the city of Łódź with drinking water. However, problems with water quality, especially this toxic algae bloom, restrict this function nowadays, and now it serves as a recreational and water sports area. When it comes to the distribution of land cover in a Soleil reservoir catchment, it is approximately 45% of arable lands, 38% forests, 12% grassland, and less than 5% urban areas. It is mainly low-density residential areas. It is on the one hand, it is good to have low-density residential area. On the other, no. I will tell you in a moment why. There are 4 communities which are located around the Soleil reservoir, and you can see in a table on the right side, there is an information concerning the water supply network and a sewage system. So we have 4 communities and 2, the smallest ones, so Mniszków and Sulejów. The percentage of the sewage system in those communities is really, really low, below the 50%. It is also important to mention that in 80s and in 90s, around in a really close vicinity of the Soleil reservoir, holiday houses and cottage houses were built, and now they transform into all year-round houses, and they do not have any connection to the sewage system. It is also according to the Polish law, because according to our regulation, it is not profitable to build a sewage network when there is less than 120 people per 1 kilometer of newly built network. So, during the fact that this is a low density area, it is not profitable to build a sewage network. So these houses are equipped with septic tanks, very often leaking septic tanks. That's why we have a huge load of nitrogen and phosphorus that come to the Soleil reservoir with point sources of pollutants. The whole catchment area of the Soleil reservoir consists of 2 rivers. First one is Pilica. It's contributing in approximately 80% and Luciąża 15%. So the load of nutrients, especially total nitrogen and total phosphorus, you may see, it is quite high a high number of those nutrients that cause a eutrophication. We have a problem with eutrophication in Soleil Reservoir during the vegetation season, usually between June and August, sometimes even in September. Of course, it is obvious that the consumption of even little doses of blue-green algae toxins, which are contained in drinking water, can lead increased incidence of cancer. But even bathing in water that contains these toxic algae blooms may cause some skin irritation, gastrointestinal symptoms, or some allergic reactions. So it is really a huge problem. Now, as I told you, the Soleil Reservoir is not a long place for drinking water for the people of city of Łódź, which has 800,000 inhabitants. Now we switched from Soleil Reservoir into wells, but it's still, as I said, very important recreational area. So the quality of water in this water body is really, really important. Of course, the Soleil Reservoir is monitored under the National Program of Environmental Monitoring, but they monitor the Soleil Reservoir only in one place. It is a place near the Zarzęcin village, so it is just a center of the lake, and they provide a monitoring of some parameters once a month. Some parameters are controlled once in 3 years, sometimes one in 6 years. So we do not have information, complete information about the changes and about the dynamics of all the processes that are taking place in this reservoir. That's why during our Monsoon project, we decided to enhance the research monitoring platform. And this platform consists of 3 monitoring opportunities, let's say, monitoring platforms. So first of all, real-time monitoring system. This system, there were two probes anchored with buoys and deployed in the Soleil Reservoir. The second system, that was a mobile floating measuring system. I would like to tell a few more words about this. This floating measuring system was equipped with multi-parameters probe, and of course offline measuring system. That means that we took water samples from the reservoir and analyzed them in the laboratory, because we know very well that some of the parameters cannot be measured in online mode. So for example, BOD, COD, phosphorus or nitrogen, we measure those parameters in the laboratory. First of all, this real-time monitoring system consists of 2 buoys. They were anchored in 2 different places of the Soleil Reservoir. So first buoy was located near the dam of the reservoir. It is buoy number 1. You can see on the upper figure. This buoy was also consist of meteorological module, because we measure not only water quality parameters, but also meteorological parameters, like for example, air temperature, humidity, wind speed, wind direction, atmospheric pressure, and solar insolations, in order to have a really full overview, not only, especially for the modeling, for the other part, to have a full overview of not only water, but also air conditions. And the second buoy was submerged near the Zarzęcin village in the center of the Soleil Reservoir, and both multi-parameter probes was equipped in sensors that could measure water temperature, pH, oxygen concentration, conductivity, chlorophyll A and blue-green algae, and also ammonia ions concentration. So the buoys were submerged to the depth of approximately 2 to 3 meters, and we measure every 1 hour. We measure each parameters, and of course those information were then visible on our website. You can also see the results. I would like to show you the results from 2015. It was the year when we start our monitoring, and you can see the blue line is a concentration of chlorophyll A, and the red line is water temperature. So we start our monitoring season in June and end in September, but you may see only a part of those. The temperature in a Soleil Reservoir was quite high, was above 20 degrees Celsius in both localizations. And the concentration of the chlorophyll A was also higher than the value for first purity class, because this value is 10 microgram per liter. Usually, especially near the dam, the concentration of chlorophyll A was much higher. So it was the first part of our monitoring. The second one was really very interesting because we did it for the first time. So we decided to take a probe from our buoy and mount this probe on the motorboat. So we built a special arm and mount now our probe together with a weight. It was necessary in order to avoid the influence of sunlight on measurements. So the probe was submerged to the depth of also 2 kilometers, and with a motorboat with a speed of approximately 6 kilometers per hour, we did a zigzag ride. So you may see this road. We start from point number 1 near the dam and finish in point 34. So it was like 7 hours of 7 hours trip with a probe. Of course, the probe was also equipped with GPS, so we had an exact position and know very well where we are exactly. The places, the numbers you can see, there were the places where we collect our samples for laboratory measurements. And it looked like that. So our probe, our arm, our boat, and the road that you may see. And so we did this zigzag ride, and then we go back just straight to the port. During this ride, we could obtain approximately 700 results because we got results every 1 minute. So all 6 parameters were measured in the same time, and during one ride, we could collect approximately 700 data. So you can see we did it once in a month, sometimes twice in a month, and the road was a bit different time by time, but it's not a problem. We just want to cover as much area as possible. And then on the basis of the obtained information, you can see on the left side, you can see the information concerning the blue-green algae concentration in a Soleil reservoir. So each dot is one measuring point. Sometimes we need to stop the boat. That's why there are some holes. But it was really good to see how the concentration of each parameters changed with the length of the reservoir. And on the basis of those information and by using ArcGIS software, we could obtain the map illustrating the spatial distribution of the concentration of each parameters. So at the end, we obtain this kind of information and these kind of maps. Here I show you only 4 parameters, but as I said at the beginning, we had 6 different parameters. I would like to show you the most important. So we have here the temperature, blue-green algae concentration, chlorophyll A concentration, and ammonia ions concentration. And we may see month by month how the situation changed in the reservoir. So I start, yes, month by month, we may see how the situation changed. So we start in these calculations or these measurements in May. So the temperature in a Soleil reservoir was quite high, approximately 17 degrees Celsius. The concentration of blue-green algae and chlorophyll A were the highest in the lacustrine part of the reservoir, so near the dam, and the concentration of ammonia ions, we recorded the highest value near the beaches and the ports, which are located in a close vicinity of the reservoir. So it was in May. Then in June, the situation was a bit different. So we have quite high temperatures, but the concentration of blue-green algae is highest in the riverine part of the reservoir, the same with chlorophyll A, and ammonia ions concentration in the central part of the reservoir. Another month, the situation a bit different. Now the temperature is the highest in the riverine part, the same as a concentration of blue-green algae and chlorophyll A. And now the ammonia ion concentration is within the norms for first purity class, only some exceeds near the Barkowice, where we have also some small beaches. And last month, so August 2015, and also another maps showing the distribution of each parameters of a water quality. The project was really interesting, and we obtained a lot of information concerning the situation and the ecological potential of water in Israeli reservoir. And it was crucial for understanding all the mechanisms and dynamics of algae blooms that taking place in the reservoir. And as I said at the beginning, we combined this monitoring data with a GEMS model. We obtained information concerning the hydrodynamic and water quality model, so we can do some scenario or some prognosis, what we should change to obtain a better water quality in this dam reservoir. And it's really, both tools are really useful for developing program measures and also the strategy for water management in this dam reservoir in Poland. So we finished our Mosul project, but 2 weeks ago we got very good information that we will be able to continue this work within another project, Promise, and I am doubly happy because together with Artur we will have chance to work together. And I think that we will obtain very nice results, and they will be important when we talk about water quality in this dam reservoir. So thank you very much for your attention.